Hey everyone, today we'll be looking at some calculations to consolidate what we learned in microbial kinetics in the previous class. Just to give a quick recap on the theoretical part before we move on to the calculations. Remember, we said that microbial growth takes place in four major phases, and then we said that in the very first phase, which is called the lag phase, the lag phase occurs here. The only thing that is happening in the lag phase is the cell increases in size. So there is an increase in size. But beyond that, from the exponential phase, we have from this point onward, we say generation starts from this point. So what happens is that the cells will start dividing into smaller or multiply into smaller cells. So that's why we say generation. So at this point, this influx, at this point, that's where your generation starts. So generation starts between that point up until the end of the the end of the exponential phase. So you have increase. So as you move from here, these other cells will divide once more. So you have more generations occurring. So but within this whole period, we have what we call doubling time within that period. So within that period, we have a doubling time. So let's look at a couple of we'll look at a couple of calculations to make a sense of that. So our exponential phase, because of this occurring, because of the relationship between the x, which is the number of cells, and time, because of that relationship, this straight line relationship, we say that exponential growth is first order. So the other thing we talk about is that it's a logarithmic growth phase, and within that phase, you see that oftentimes the calculations we carry out are based on mean values. So we use the natural log values to get our values. So a couple of notations that I want you to know their definitions. You need to know what they are, because in the next couple of examples, we'll be using the equations we'll be using will be this and that. But you need to know what everything stands for, so that when you're doing the calculation, you know what you know what you have and what you're looking for. So tau d, that is the doubling time. Tau is the generation time. Remember, I said earlier on that we have multiple generations occurring within the exponential phase. But if you look at some more examples, you see that in some instances they actually equate them to mean the same. But it will make sense of that in the next couple of slides. So that is that. And your x1, that will be the initial concentration of your microbes, and then the x2 will be the second concentration of your microbes. So that's what those are, or your microbial cells. So it tells us that on the y-axis we have our x, and then on the x-axis, that's where we have our time. So that means your tau values will be on this axis, will be on that axis. So let's look at an example. Example 1 says, what is the generation time of a culture with, and remember we said culture, same thing as cells, microbial cells. What is the generation time? So what you're looking for is tau. We use that formula with a specific growth rate constant of 0.01 per minute. That is mu. And then this B part of the question is at what speed. So let's start with the A part. So we just substitute what we've got. We've got it's 0.693 divided by mu value is 0.01, and then we have, and remember, you always need to take note of your unit. So it gives us 69.3 minutes. But please take note, for tau values, either this or even your tau d, the conventional unit is hour, not minute, not seconds. So what that means is that your answer is incomplete at this point. So you need to convert this to hour, and you simply just divide 69.3 divided by 60, and that should give us 1.55 hour. So that would be a tau value. And then the B part of the question is at what speed. So speed is just the inverse. It's represented by K. It's just the inverse of your tau. So we just say 1 divided by, this should be 1.155. Please take note of that, correct that. That's 1.155 if you punch that into your calculator. So it should be 1 divided by 1.155, and then it should give us 0.8658 per hour. Units, remember, when it comes to your calculations, units are very important. So you need to ensure you write the proper unit. So this is the A part. This is the A part. That's the B part. So this is the speed, and that is the generation time. All right. Example 2. With how many bacteria? Same thing. We've said bacteria, cells, or your culture. With how many bacteria should a culture be inoculated to reach 10 raised to power 8? So this, we can take that as our x2. After 3 hours, if the generation time is 30 minutes, so that is a tau. So we've been given those two. But let's try and make sense of these values on this graph. Take note, it says inoculated. Inoculation starts at time 0. Inoculation starts at time 0. So now it says after 3 hours. So that means our time is from here, somewhere there, 3 hours. And I'm saying somewhere there because our x2 will be, we can say our x2 is here. Yeah. So this would be our T1. And then because it says inoculation, so that tells me that this point would be our x1. It can also, might also say that, you know what, x1 or x0, because it's at the beginning. Remember, inoculation is at the beginning, but remember, between here and there, the number of cells, there is nothing, and the number of cells are not changing. So that's why either we say x0, we say x1, but the bottom line, the one thing I want to take note of is it says inoculated. So inoculation is at time 0. But when we start talking about generation is from this point to that point. But because they said inoculation, so inoculation is from that point to that point. I'm emphasizing this because you might have a question where they indicate the lag phase. So if they indicate the lag phase and you're looking for what occurs during the generation, that means your calculation will be between this time and that time. So, but let's look at this question critically, and then I'll try and mention that other scenario as we move on. So we've got that. So what we need to do is we've identified what we have, and then want to see how do we get what we don't have. So all we just need to do is, we know that we've got this, which is common to both of them, which is common to both of these two. So if we make mu the subject of the formula for equation 1, equation 2. If you make mu the subject of formula for equation 1, it becomes equation 3, and that will be mu equals ln 2 over tau. So we can equate equation, we can say equation 2 equals equation 3. Equation 2 equals equation 3. So that takes us to ln 2 over tau equals ln x2 minus ln x1 over change in t. Remember, change in t is same thing as t2 minus same thing as your t2 minus t1. So it's same thing, but let's just take it out of there. So that's your change in t. So if you so what you're looking for is so want to make what you're looking for is x1, what you inoculate at the beginning. That's what you're looking for. So we want to make ln x1 the subject of the formula. So that's what we want to do, make ln x1 the subject of the formula. And then when you do your cross multiplication, you should end up with ln x1 equals ln x2 minus, I've skipped a couple of steps, but I'm sure it's something you can easily figure out. Change in t ln 2 over tau. So you first remember, you cross multiply, and then you make your ln x1 subject of the formula. So all we then need to do is substitute the parameters we've got. Remember, the final number of cells is 10 raised to power 8. So ln 10 raised to power 8 minus change in time. Remember, it's for the whole period, so 3 hours. 3 multiplied by ln 2. Ln 2, if you punch that into your calculator, 0.693 divided by tau. Remember, tau is 30 minutes, but you need to convert it to hour, 0.5. Always remember that consistency of your units. And secondly, everything that has to do with time in microbial kinetics, you need to convert it to hour. So if you punch those into your calculators, we will get 18.4207 minus 4.158. So ln x1 equals 14.2627. And then remember, when you need to get rid of your natural log, you need to find the exponent. So it will be x1 equals exponent of 14.2627. You can punch that into your calculator, and then x1 gives us 1.56 times 10 raised to power 6 bacteria cells per mil. So that is our answer. Remember, the scenario I was trying to explain earlier on was assuming they said assuming you have the equation and it says there was the question, and it says there was a lag phase. But they said from the beginning of inoculation to when you have the final so for example, they say your x1, as we mentioned earlier on, happens at 3 hours. So that means from the beginning, inoculation to that final place is 3 hours. But assuming you have an equation that says there was a lag phase of 1.5 hour. And remember, this is where growth is happening, regeneration. So what that means is your change in time wouldn't be 3 hours. Your change in time will be what? 3 minus 1.5. So this, if you are given, take note of that, if you are given lag phase, if you are given time for lag phase. This will happen. But in this particular question, what we are told is from inoculation, so from beginning to the end. So that means this, we wouldn't take this out because it's not just the generation time we're looking at. We're looking at from the beginning. So please just take note of that. So let's look at a final example. How long would it take for an initial population of 10 raised to power 6 cells? So what would that be? What would 10 raised to power 6 be? I mean, what does this stand? What's that? That would be x1. Good. To reach a size, what would this be? That would be your x2. If the generation time, what is 30 minutes, that would be our tau. So we take note of what we've got and then we try and look for what we don't have. So as we've done previously, so x1 will be here, x1 is there, and that is, remember, this is where the time starts. This is where the generation starts. So T1. X2 will be somewhere here. So x2, so at T2 will be there. So what you're looking for is change in time. That's what you're looking for. So take note of that. So between this and that time. Another thing I want to take note of is you see that for all the examples, I always draw the point for x2 below this point. The reason being that this is where you have your maximum growth. And the question doesn't indicate that it was maximum growth. So that's why I've drawn it below that point. All right, so let's move on to our calculations. So it always makes it easier or clearer when you try and put it on the graph. It always makes it clearer. So let's move on with our calculation. So same thing as we did in the previous calculation, make mu your subject of the formula. If you make, so we have equation 1, equation 2. So equation 3, big mu is ln 2 over ln 2 over tau. And then we can equate 2 and 3, equations 2 and 3. Then we have, so equation 2 and 3, and then we have ln x2 minus ln x1 over change in time. Change in time equals ln 2 over tau. Since it's change in t that we are looking for, so we can make this is what you're looking for, so you can try and make it the subject of the formula. Same thing as we did previously, cross multiply, and then after you cross multiply, you should end up having that. I've skipped a couple of steps because I believe you can figure it out. Ln x2 minus ln x1 over ln 2. So all we just need is substitute our values. Remember your tau, you must always convert anything that has to do with time, you always convert it to hour. So our tau is 0.5 from 30 minutes. We have ln x2, that's the highest point of our cell number, 10 raised to power 8. The starting point, 10 raised to power 6. And then ln 2, if you point that into the calculator, 0.693. If you multiply that with the values, okay, let's do that. Just point that into the calculator, please. Your ln 10 raised to power 8 will be 18.4207 minus 13.8155 divided by 0.693. Change in t equals 0.5, 4.6052 divided by 0.693. That gives us 2.3026 over 0.693, which should give us 3.32 hour. I'll advise that anytime you're carrying out any calculations, show the stages so that even if you miss some part, you still be able to get the rest of the calculations. So those are our advice. You carefully look through these examples. You can bring yourselves together in groups to look through them together. But if you still have any query, don't hesitate to give me a shout. You can send me a WhatsApp message or send me an email. All the best.